Hello, hello. Welcome to today's webinar. We'll get started in about a minute. Thank you for joining us today. Hello, all. We'll give it a few more seconds. I see some people are starting to trickle in. Thank you for joining us today. All right. Well, I just want to say welcome. Thank you guys for joining us today for What's New with Tanzu RabbitMQ 4.1. Today we're joined by two very friendly faces. We got Howard and Greg. Thank you both for joining us today. Before we hand this off to our speakers, just a few housekeeping items. We'd love to keep this as interactive as possible. So if you have any questions for us, we hopefully will have the answers. So submit them using the Q&A tab on your screen. Our team will see them and we'll be able to answer them at the end of today's presentation. Now, without further ado, I'll hand this off to today's speakers.
Excellent. Thank you very much indeed, AJ. Well, hi, everybody. Thank you very much for taking the time to join today's session. My name is Howard Twine. I'm the product manager for RabbitMQ. I'm based in the UK, where it's unusually sunny at the moment still for the spring, which is nice. And I'm responsible for both open source RabbitMQ as well as Tanzu RabbitMQ, our commercial offering, and all of its various forms. Greg, why don't you go ahead and introduce yourself?
And hello, everyone. My name is Gregory Green. I am based out of the United States. I'm a solution architect. I have the privilege of working with awesome people like Howard, and I also have the pleasure of going to our various customers at VMware and Tanzu and just kind of showcasing how awesome our data products are. And I'm excited for today's conversation.
Excellent. Thanks, Greg. So yeah, let's just run through the agenda. We've quite a broad agenda for today, as well as the title says, yeah, we're going to talk about what's new in RabbitMQ with the release of 4.1. But before we get on to the main features of RabbitMQ, I thought we would take this opportunity just to take a snapshot, a step back at what RabbitMQ is, the problem that it solves, and why VMware Tanzu RabbitMQ is relevant. So, yeah, fundamentally, just sort of moving on from that, what is Rabbit and why? And Greg, you see this almost every day. What are the sort of typical kind of challenges that folks are and problems that people are facing in the real world and solving with a message broker like RabbitMQ?
Okay, great. In order to understand why it's important, something a solution like RabbitMQ is important. So Howard, imagine that you are a consumer application and you receive publisher requests from other apps or systems. Now, these requests might be a command to do something, or it could be a purchase order for a very popular product, or it could be user information to register for some program, some critical life-saving program. Now imagine you have hundreds, thousands, even millions of requests that you must satisfy immediately. If you are overwhelmed with requests, you have to let somebody down. You might lose that customer who can't buy that product that they are so excited about. Or worse, because of your poor design, Howard, you might prevent that person from registering for fraud from a life-saving program. So also, if you need to save that published data into a database, well, what if the database can't handle it, right? You just can't keep retrying forever to save that data into the database because more and more requests are coming into the systems that must be a process. So, next slide, please. So for all of these challenges that I talked about, like RabbitMQ is a perfect solution, right? First, Rabbit introduced a what I call an opinionated design for applications where they segregate responsibilities. You have publisher applications They're just focused on safely publishing data requests in the form of messages to RabbitMQ. And then you have consumer applications that they're focused on consuming data reliably from RabbitMQ. So if there are hundreds, thousands, or even millions of published requests, like Howard, you don't have to worry about it, right? A well-designed RabbitMQ deployment can handle it. It allows consumer applications to process those messages at whatever rate is needed to satisfy the business requirements. And it will not overwhelm the consumer applications. And most importantly, it adds reliability. This prevents the loss of critical data, and it eliminates turning those exciting customers away with messages like, sorry, the system is busy. Try to purchase this great product again sometime later, right? And Howard, can you talk about the simplicity of RabbitMQ?
Yeah, I certainly can. Rabbit isn't, one of the most popular, if not the most popular queue-based message broker in use today by accident. You can deploy it pretty much anywhere. In terms of availability for Rabbit, it's everywhere. But one of the things the team gets asked quite a bit is, how many downloads have there been of version XYZ kind of thing. And I'll be honest with you, we struggle to come up with stats like that because there are so many different ways that users can consume Rabbit. You can get it through the Broadcom support portal for the Tanzu branch, but in terms of the open source variants, you can get that absolutely anywhere, and you can, as I said, get it in OVA formats. We've just released an RPM for 4.1. There are OCIs, and we've got FIPS specific builds for Federal Information Processing Standard builds for RabbitMQ, for Tanzu RabbitMQ as well. And of course, it's available on Tanzu platform for Cloud Foundry. It's available as a tile on that. And when you look at the Docker images, RabbitMQ has been downloaded more than 1 billion times from the Docker website, so it's everywhere and is really easily available. But it's not just the availability that makes RabbitMQ as popular as it is. There are some really simple tools. Even myself, I rely on things like the management UI within Rabbit to make sure that it's actually up and running and it's healthy and simple, for a simple kind of deployment that somebody like me would actually use. But when it comes to using it more at scale, the CLI tools that exist, as well as the many different configuration tools that exist for Rabbit, and the monitoring using Grafana, you can go to the Grafana website, download a standard Grafana dashboard, and bang, you're monitoring potentially larger scale instances of Rabbit. And then there's the protocols. Not every message broker out there has anything like the broad range of protocols that exist in RabbitMQ. It's been around for 18 years now, and it was built on AMQP 091. But recently, with the 4.0 release, we've increased the breadth of deep, sort of what we would refer to as native AMQP 1.0 support, which is a more widely used protocol. So we also have done the same historically with MQTT, which is the IoT protocol of choice. And then we've got things like Stomp and should be on the list there, streams. You can do streaming with Rabbit, just like folks that tend to lean more towards Kafka seem to think that Kafka does streams and Rabbit does queues, and that's the end of it. It's not. It's wider than that. And then there's the information, the availability of information for RabbitMQ, the docs. You only need to go to rabbitmq.com and look at the breadth of documentation in there. And recently, the core engineering team redesigned that website to make it easier for users to access technical information about features within Rabbit, and that, as I say, the depth of that information is very, very deep. And the same also goes for Tanzu RabbitMQ. The tech docs for Tanzu RabbitMQ, again, through the various support portals and what have you that Broadcom has, there's a wealth of information at your fingertips. But I'm talking here just about one side of the story because it's easy to be able to stand up an instance of RabbitMQ, as you're going to demonstrate a little bit further on, Greg. It's easy to get the instance up and running for the core server, but as I say, that's only half the story. You've got applications that you need to build, and having client libraries that are just as accessible as the core is critical. And client libraries in as many different languages as we can possibly support, from Java, Java.NET, Python, Node.js, and so on, to support all the protocols as well. With 4.0, we released native support for AMQP 1.0, and we've been rolling out updates to the client libraries independently of the server releases as well. And we're still maintaining the AMQP 091 client libraries as well, but it's important to know that there are these client libraries available out there. But I've talked about the server, the client libraries, and what makes Rabbit so kind of simple. But I couldn't say for this slide, I couldn't say the elephant in the room because we're talking about RabbitMQ. So the rabbit in the room here is the fundamental reliability of Rabbit. There are so many customers that we have out there that depend on Rabbit, and if their messaging infrastructure isn't reliable to the microsecond, they lose potentially millions of dollars. And when banks lose money, all bets are off. So the reliability of Rabbit and its robustness is, absolutely bomb-proof. The message delivery guarantees that are built into Rabbit. You don't have to do anything clever. These features exist natively within Rabbit, in the same way that the clustering does as well. And I've heard stories of people using the sort of classic mirrored queues because they thought they had to mirror the content on nodes across a cluster. You don't need to do that. Rabbit handles all of that for you. And perhaps the biggest reason is this clearly defined messaging model that implements sort of standard messaging patterns, whether it's pub/sub or work queues, using exchanges and queues, and the fact that the default message exchange, that hides a level of complexity for people that just want to get going. But it can also scale out to way more complex forms of configuration with Rabbit, with direct exchanges, fan out, topic exchanges. There's an extensible list, and this gives a level of flexibility within the configuration and the design of your messaging topology that no other message broker, obviously I'm biased, but no other message broker out there can provide. But this all sounds great on paper, Greg, but what about the real world? How does this flexibility really impact customers out there in the real world?
Yes, sir. I've had several conversations with customers that are challenged with sending data, that critical data, to applications or systems that are um, I'll just say that they're unstable, right? And there may be many reasons why there may be instability in the systems. Maybe it's a custom application that's exposing an application programming interface, and maybe it was just implemented poorly, right? Maybe this is part of what we call greenfield development, or it may be a lack of scalability in the design of some commercial off the shelf product, right? So just in general, Rabbit has the ability to add scalability to these solutions, right? Next slide, sir. And this is an architecture that I typically propose using Rabbit and Spring, right? So both the Spring framework for Java applications and RabbitMQ are part of the VMware Tanzu software family. With Spring, you can quickly deploy open source applications to expose API or application programming interfaces to deliver messages to Rabbit at scale. And you can use various Spring projects that can reliably deliver those that data to even the most unstable application or systems, right? Because as Howard mentioned, there's just out of the box features like something called flow control, and there's replay capabilities built into Rabbit with the Spring APIs. And actually, let's just show you something. So as I always love to do, I have an application, a demo application that I developed. So let me go ahead and share my screen. So this is the application. It's a Spring-based application. So in here, I have, think about this. This is like registering account information for, like I said earlier, some life-saving program, right? So I have two buttons, two options, right? So I have the reliable button and I have the flaky button, right? I don't know if flaky is a term in the UK,
Oh
Howard,
yeah,
but we got
yeah,
so
yeah.
basically, there's a flaky API. I wrote the flaky API intentionally, okay? Uh, so the flaky API, it's just going to fail the first two requests for like it's going to return either a timeout exception or too many requests exception if you're familiar with HTTP responses, right? But the reliable way is basically going to use a couple of applications. So again, this is RabbitMQ running locally on my machine. I started, it was like super easy to get started, right? I'm running it in a containerized environment in Docker or in Podman. You can easily get it started, right? So it's just a single RabbitMQ instance. And this is the dashboard that Howard was mentioning, right? So I have one node or one broker, and I have some exchanges. This is basically how the applications would send information to an exchange. And I didn't have to create these exchanges, right? The awesome people were part of the RabbitMQ team. They pre-configure these things for you. And when I start up my application, again, I have a queue, which is the destination, to reliably deliver this data to this application, right? And also, I wrapped the sending, so I send data to Rabbit, and then I have another app that is going to get that data from Rabbit and try to send it to this flaky API. And I'm using another framework called Spring Cloud Data Flow, right? So this is the app that's basically just trying to reliably send it to the flaky API. So let's suppose if I put in another user account or another account, and I'll use the flaky API, right? So again, the flaky API is going to give me some errors, right? It's I do it two times, it's always giving me an error. The third time, it's gonna say okay, right? But if I do the third time, and I have another app that actually shows you the data. So this is the app that shows you the data, right? So this is the third one we just created. Now let's create a fourth one. So now the fourth one is always going to be successful right away, right? Because again, it's just sending it to RabbitMQ, right? And if the flaky response, the flaky API is failing, it's just going to just keep retrying till it actually gets in there, right? So that's just an example, a quick demo that I wanted to share with the folks. All right, I'm going to stop sharing. Howard, if you can share.
There we
All right.
go. And
Thank,
you on the next
thank,
slide.
thank you, sir. All right, and I'll just say that many of our customers are on a modernization journey. They're going from monoliths, I should say, to microservices. And some of our customers are focused on APIs for their microservices, and they're not using any messaging solution. And some of them experience these pain points that are highlighted on the screen, right? So some mentioned that it's hard to evolve a particular service because it's tightly coupled. They may have performance issues where one application impacts another, and things just in general might get complex or disconnected. So this is an opportunity for RabbitMQ. Right, next slide, sir. So RabbitMQ just addresses those issues, right? First of all, I'd like to say that it unlocks innovation because information that is published from one app can be easily shared to another app just through configuration without weeks of or months of application development. And it's extremely performant and stable. In fact, it's so stable, it's kind of boring because it just works out of the box. And I'm trying to tell you that for your business, right, you can trust it for your mission critical workloads, right? And it's used by many different companies to connect data of all kinds, right? And next slide, sir. So at VMware Tanzu, the team is making the RabbitMQ that most of you love. We're only making it better. So we're going to dive into why Tanzu RabbitMQ. Right. So the first thing is that we're making Rabbit easy to use. And of course, you can deploy RabbitMQ on bare metal or on a virtual machine. And we have some optimizations when you run on vSphere, but we're also making it super easy to deploy in a containerized environment like Cloud Foundry or any flavor of Kubernetes. And the team is saving you time and money, saving you the time and money that it takes to manually provision and maintain RabbitMQ deployments. And they have built-in concerns for high availability and fault tolerance that are just ready for production. Next slide, sir. And this slide is an example of using the RabbitMQ operator, right? The operators in Kubernetes, or what's called a tile in Cloud Foundry, they basically become an extension of the containerized platform. The RabbitMQ team has developed the operator to accept this simple text file. And it basically is going to create a load balance cluster of 5 RabbitMQ brokers. And actually, I have an example of this. So we're going to do this live, right? So I'm going to go ahead and share my screen again. Okay. Okay. So now you should be able to see my YAML definition, right? So with this is, again, at the end of the day, this is going to create a RabbitMQ cluster of 5 nodes. And in this case, I'm just using Kubernetes. So behind the scenes, what I'm doing is I'm basically using Kubernetes, and I have a cluster, the operator installed into a public cloud, and within a couple of minutes, we're going to be able, it's going to read this definition, and we're going to have that 5 cluster or 5 broker instance of RabbitMQ, right? So actually, let's just go back to the slides, sir.
Sure. There we go.
Okay, great. So this just speaks to how easy it's just making it for the operators and developers. Next slide, sir. So now I will say I love working. I'm gonna share a little secret with everyone. I love working with Howard, right? My colleague Howard. He is such a humble and extremely patient and kind individual. But I think personally that I would test the limits of his patience and kindness by manually trying to set up a 5 node cluster during this webinar without using these tools like the operator on Kubernetes or the tile on Cloud Foundry. But these tools allow Howard to continue to be patient with me during these webinars because it's provisioned in this cluster as I'm speaking, right? and it will be ready for this demo in a couple of minutes. And it can also be ready for production for you. It's handling the common concerns after production, like, for example, keeping RabbitMQ up and running. It not only knows if Rabbit is healthy, but it also knows how to heal it, right? It makes everybody happy. It makes Howard happy during these webinars. It makes your developers happy. It makes the life of the administrators that need to maintain and upgrade these systems over time. It just makes their job super, super easy. So again, while this is provisioning, Howard, can you tell us about RabbitMQ recent releases?
I can, yes, with a big smile on my face. Thanks very much for that, Craig. Yeah, so while that's provisioning, I thought we're kind of heading towards the part of the presentation where I talk a bit more detail about what's new in 4.1. But like with any roadmap, it's just as important to a degree to know where you've come from as it is to know where you're going. And when you look at the last sort of year and a half, the last 18 months or so, and the releases of RabbitMQ, both open source and Tanzu RabbitMQ, you can see we've been on quite a journey. Certainly, back in September 23, we launched support for native MQTT, and that was a real test for the team to be able to support a different native protocol at the core of Rabbit. And that was a tremendous success. The performance improvements for previously supported protocols, in this particular case was MQTT3, the performance improvements were just vast, absolutely tremendous. So of course, we're on a roll there. So we started to roll out support for MQTT5. That came in 3.13, and we also broke the mold with the naming convention, because historically, before that release of 3.13, we had different release numbers and a different release cadence as well for Tanzu RabbitMQ, as well as open source. In fact, I think when you were kind of trying to work out what version of Rabbit you were on with Cloud Foundry, I think you needed a degree in mathematics to work out exactly what version it was. We've simplified all of that now, and certainly with 4.0, not only are the version numbers aligned, but the releases are aligned. And we released on time with 4.0 in October last year, and we've done exactly the same with 4.1. We released the open source 2 weeks ago, and then a week later, the team released Tanzu RabbitMQ 4.1 as well. So we've done away with this kind of loosey-goosey kind of release cadence for Tanzu Rabbit versus open source Rabbit, and that's something that the team have wholeheartedly embraced, and we now have a much more regular release cadence. One of the net results of this is that actually we're able to have a more clearly defined support model for both open source RabbitMQ and Tanzu RabbitMQ. And the headline here is that certainly with 4.0, we also launched a long-term support version of open source RabbitMQ, which is 3.13. And that's still going. In fact, it's going to continue to go to be supported and patched and maintained until the end of December 2027. Now, there's a reason for that, and that is that we want to give our commercial customers, our Tanzu customers, the opportunity to plan ahead and get onto the 4.0 branch without kind of forcing them to do that, but also making it slightly easier for the engineering team, the core engineering team within RabbitMQ, to manage and maintain a more sensible array of releases. So we no longer support open source 3.12. 3.13 isn't supported through the open source community, but Tanzu VMware customers get support for 3.13 as well as for 4.0 and 4.1. In fact, for open source open source users, not commercial customers, the only currently supported version of RabbitMQ is 4.1. And this will continue. We'll have this sort of rolling process when it comes to updates. Now, Greg, how about that deployment? Have I put the webinar commentary of doom on your deployment, or is it up and running and done?
Yeah, like we said before this started, like it's RabbitMQ, like it just works.
Yeah.
So yes, the five I was feverishly working behind the scenes, and now you see that this cluster of five brokers is up and running. Actually, it's been sitting here and waiting. You see the uptime for about 6 minutes or so, right? So again, it's just the management console that everyone loves. If I had some connections, you actually see the connections here. You see the pre-created exchanges, the queues. One thing that's really cool is that the cluster operator, it actually creates a default user. Now you can always go in here and create your own users. But again, it like disables things like the default guest users. Please don't deploy that in production, people. So yeah, so it creates a randomized user for you that you could always add to and administer in change, right? So now that we have this cluster, right? What I also want to do is let's go ahead and upgrade it, right? So we talked about this operator is also simplifying the ability to upgrade this cluster, right? And all I need to do is upgrade this cluster is just change the image that I'm using, right? So behind the scenes, what it's actually going to do, it's going to change each one of those nodes. It's going to upgrade them from 4.0 to 4.1, but also it's doing it in a way that it minimizes the impact to the actual system, right? So it's doing it in a rolling upgrade sort of fashion, right? So we'll gradually start seeing nodes disappear. So one of them has disappeared. So it's being upgraded, and when it's fully upgraded, it's going to be put back into the cluster. So while that is going, take a minute or so. So while that is going, Howard, if you could go ahead and share those slides again. So yeah, let's talk about the benefits of 4.1 as I'm upgrading this.
Yeah. Thank you, Greg. So yeah, we'll start with an overview here, so that you can see side by side the differences between open source Rabbit and Tanzu RabbitMQ with this release. Um, and we've made some fundamental performance improvements with this release. I'm going to delve into that in a bit more detail in just a moment. We've also got a new JMS queue type. I'll delve into that as well. And we've made quite a significant, but although it's small, it's quite a significant update to the Kubernetes cluster operator, funnily enough, Greg. But there's one change here that is really quite significant, and that is that we've changed the model with feature flags within RabbitMQ. We used to have just there was only one behavioral type really with feature flags, but we've kind of made that a bit more granular and made them sort of hard and soft. And these new properties of required feature flags make it easier for upgrades. And what this actually has led to for Tanzu RabbitMQ is the fact that you can now skip upgrades. So you no longer have to step through incrementally from, let's say, 3.13 to 4.0 to 4.1. If you're running 3.13, you can go straight to 4.1. And as we go forward, when we release 4.2 later on this year, you'll be able to upgrade from 3.13 to 4.2. That's the plan, and that's sort of underpinned with this new feature flag model. And earlier on, I talked about the toolkits that are available, the tools that are available within RabbitMQ. And one of them that I'm really quite excited about is a completely refactored RabbitMQ admin. We're sort of internally referring to it as RabbitMQ admin v2. It's now its own self-contained binary, so you don't need an Erlang library on whatever you're hosting it on to run, which might be away from the RabbitMQ cluster itself. It's lighter weight. It's easier for the team to maintain. And it's got some really nifty features, and I strongly recommend to sort of seek it out, because one of the things that we're kind of continuing to evolve is the ability to perform transforms with the RabbitMQ cluster, with the RabbitMQ admin v2, and the transforms will make it easier to sort of trim down, modify policies, especially when it comes to things like classic mirrored queues. When classic mirrored queues are removed, removing the mirroring and making modifications around that. Tanzu RabbitMQ, I mentioned the skip upgrade thing. That's a big thing. I know Greg's very excited about that. But also specific to the Tanzu branch, we've got WebSockets for AMQP 1.0. I'll delve into that in a little bit more detail. And we've now got an RPM. We've had an RPM for open source RabbitMQ for a little while now. And yeah, it's taken a while to build a Tanzu RabbitMQ RPM. We've got a few small updates to the OAuth2 plugins for Tanzu RabbitMQ. And we've also made some improvements to warm standby replication. So the headline that I kind of started off here was the CorumQ performance improvements. There's two fundamental changes that the team have made that contribute to this. The first one is offloading the disk reads, bearing in mind that CorumQs are durable queue types. And this change modifies the way that the data is written to disk on a sort of channel session basis. And the other is the actual data structure to the backend library that CorumQs use. And this library holds the segment files for CorumQs. And it's now much, much faster, especially when it comes to scanning the right segment to read from. And remember that RabbitMQ isn't all about memory, and it's not all about disk. There are some folks who say Rabbit only ever does stuff in memory, and some say, everything's all done on disk. There's quite an intricate relationship between both disk and memory, and I strongly encourage you to have a look at RabbitMQ.com. There's a blog post there that explains how messages are stored within Rabbit. But let's go back to these performance improvements, because I want to show you this graph, because this was kind of a bit of an oh wow moment for me when one of the team shared these findings. So what we've got here is a graph showing a 3-node cluster, and each of the plots on the graph show the memory usage over time for 5 CorumQs running across these 3 nodes. And they're typically handling about 100 messages per second. So a total throughput, each queue is handling about 100 messages per second. So we've got a total throughput of about 500 messages per second. But if you look at the plot halfway through, it actually looks like the cluster's died. But in fact, the offset between each of those colors, the red, blue, and yellow traces there, that was during a rolling upgrade, which funnily enough is what Greg's doing right at this moment. But the bit after that point, where it kind of falls off a cliff and it looks like it's flatlined, is actually the memory usage after the 4.1 upgrade. We're going from 4.0 to 4.1 here, and you can see that the memory usage is way more consistent and way more stable. Now, it's important to bear in mind here that a lot of this depends on the way that you're publishing to Rabbit, your connection, the message size. There are lots of factors here. But the feedback that we've had from users in the community is that actually for quorum queues, we've pretty much doubled the throughput and at the same time halved the latency, which is absolutely tremendous. So that's a massive win for this release. But we've also made performance improvements for WebSocket connections. RabbitMQ serves up HTTP connections using an Erlang HTTP server that was written by one of the engineering team before he actually joined the RabbitMQ team. And he's tweaked this library in 4.1, and the overall performance for WebSockets for both AMQP, MQTT, and Stomp has been quite significantly improved. But there's another benefit to this work, which is the team took a look at how these improvements were rolled out in that Erlang HTTP server library and thought, well, hang on a minute, we can apply this to our own AMQP listener. And that's exactly what they've done, which means that Rabbit now uses less memory for AMQP 091 and 1.0 connections alone, irrespective of what I've just been talking about now with respect to disk and memory usage for quorum queues. For general TCP connections, there's an improvement as well. And we've got a new JMS feature in 4.1 as well. And this maps really quite nicely into AMQP 1.0. So Rabbit's had some fairly good support over the years for the Java message service. But the core of Rabbit has always been biased towards AMQP 091. And that was always a bit of a compromise. But since the launch of native AMQP 1.0 last year in RabbitMQ 4.0, this restriction's been lifted. So over the next sort of coming releases, you're going to see more JMS type features in RabbitMQ, and this is going to allow AMQP clients, in this particular case, AMQP clients can create RabbitMQ exclusive queues which map really nicely to JMS temporary queues. So you pretty much almost got a drop-in replacement for some legacy brokers out there with RabbitMQ. This also supports the creation of these temporary queues over AMQP, utilizes the Apache Cupid JMS client. So again, from a client point of view, if folks are using the Cupid JMS client, again, you don't need to make an update to your client. You can just drop RabbitMQ in straight away. And these temporary queues, by the way, are deleted when the session is closed, either when the link is detached, the session ends, or the connection closes. So quite an elegant solution there. And 4.1 also sees a new and improved approach to peer discovery within the Kubernetes cluster operator. Previously, peer discovery was performed by querying the Kubernetes API server for a list of endpoints behind a specific service. Kubernetes automatically registers pods for a given stateful set. It registers them as endpoints. However, there's a couple of issues with this. Some users reported that occasionally the cluster formation would fail, and the pods would actually end up forming multiple separate clusters as opposed to one joined up cluster. It also required different permissions to query the Kubernetes API, which wasn't really a big deal, but it was just a bit kind of clunky. It was also a bit of a sort of a convoluted way of asking, what the sort of pod setup was. Now with 4.1, when deploying to Kubernetes, you can actually you should always use a stateful set, and all pods that belong to a stateful set, they're named consistently, and they're named with the name of the stateful set followed by an index. And that index is configurable, but it almost always starts at one. Sorry, starts at zero. Freudian slip there. Yeah, always starts at zero. Now, given that, a 3-node cluster would always have its node suffixes of 0, 1, and 2. So if you know that, you don't need to query the Kubernetes API to do that. So long and the short of it is it's way more efficient. It's backwards compatible, and there is an advanced config for all of this. And it only ever runs, I should clarify, it only ever runs on the first startup of a node after a node's been created. So again, a more efficient way when it comes to deploying RabbitMQ. We've got a couple of updates to AMQP 1.0 in this release as well. AMQP 1.0 now publishes to the event exchange in Rabbit, which for Tanzu RabbitMQ means that AMQP 1.0 features appear in the audit logs. We've got some updates to the JSON Web Token, just a tiny update allowing refresh for JWT tokens before they expire. And we've got a new feature for streams for AMQP 1.0 for filter expressions. This is a more explicit approach than previous releases. The previous release Bloom filter that we launched a while back, this is exclusive to AMQP 1.0. The Bloom filter approach could return false positives. This new filter allows for multiple values to be assigned for both publisher and consumer. And users can filter on various different message properties, message ID, type, subject, etc. And again, this does come at a slight cost. There is a broker overhead to this because obviously there's work that Rabbit needs to do at the core. So there's slightly more of an overhead with this type of filtering than the Bloom filter, but then it's more explicit, so there's more work being done. Again, check out the blog post for more details on this on rabbitmq.com. I mentioned earlier in my overview that we've got an RPM, so we now have parity with open source RabbitMQ. So this it makes it easier for in-place upgrades. Some folks struggle with in-place upgrades with the OVA, for example. So the RPM is a little bit more flexible there. And we've got for Tanzu RabbitMQ, we've now got support for WebSockets for AMQP 1.0 over WebSockets. Now, Rabbit's supported WebSockets for both Stomp and MQTT for some time. And the benefits of WebSockets generally is browser compatibility. It allows browser-based applications to use the application layer protocols other than HTTP. For security reasons, browsers restrict JavaScript from opening raw TCP connections to communicate using protocols like AMQP or MQTT. But WebSockets protects against that malicious JavaScript running, for example, in a browser. Therefore, you're enabling a secure application layer for communication using WebSockets. And it's also firewall friendly as well. So you've got quite a bit of flexibility there. We had a customer that was actually using Stomp and AMQP 1.0 because they wanted, they were using AMQP 1.0 for other things, but they had to use Stomp because it was the only way that gave them the WebSocket interface. Now they can use AMQP 1.0 throughout the whole of their messaging topology. And as we head into the final straight, Greg, I just wanted to just highlight Capri, which was the new metadata store that we released last year in 4.0. It's proving to be very, very successful in solving some of our users' problems. Um, at some point later this year, Capri will become the default metadata store for new clusters, only for new clusters. It is possible to upgrade, um, but only upgrade from the 4.x branch of RabbitMQ. But it is also proving to be really quite performant. And we are seeing more and more users creating clusters that span multiple availability zones or data centers that might have network latencies that would have caused the old metadata store within RabbitMQ to have issues. So we've significantly improved the resiliency of RabbitMQ in doing this. And on the topic of resilience, we've also made some improvements to warm standby replication. Not all of our users have an OAuth implementation or provider. So a popular alternative to this is X509 certificate. We've now added that form of authentication. We've also got OAuth support in warm standby replication for the stream link as well. We've got API controls now for the schema replication process. We've been growing out the API commands to give greater flexibility and easier control to users for warm standby replication. And we've also got a downstream cluster guardrail that prevents publishing of messages to the downstream or passive cluster until it's ready. And this is during the promotion process as well. So we made the promotion process a lot more robust in doing that. So Greg, that's the end of my update. Have you finished doing this upgrade on your deployment?
Yes, sir. It is all done. I'll show it in a minute, but I wanted to talk about my favorite. All of those updates I think are amazing. Great job and kudos to the team. But if you go to the next slide, this is really my favorite of all of the features of 4.1 is the AMQP filtering using streams, right? Again, definitely my favorite new feature for 4.1. And of course, I had to make a demo, Howard. So in this
Okay.
demo, I'm showcasing the power of filtering. So it's going to be filtering account registration data from a single source application to in this case, two applications, but it could be multiple applications. It can be hundreds, even thousands of applications, right?
Nice.
Um, and
It,
the
it's
great
going to have
thing,
to be a quick one, Greg. Sorry to interrupt. It's going to have to be a quick one because we've only got 6 minutes left.
oh, okay. Yep, yep, yep. So the great thing about streams is that again, it can handle those thousands or millions of ways to filter the data. When you just send it to one stream, it can filter out that many different ways to different consumers. Previously, you had to have, for example, thousands of queues or even like a millions of queues, which that would not be reasonable for a RabbitMQ cluster. So as we wind it down, let me go ahead and share the solution. First of all, I just want to show you that here, this is RabbitMQ. It's all upgraded. So the 5 nodes been upgraded to 4.1, but I already have some applications up and running. Those applications are using the AMQP 1.0 spec, and it's actually created, for example, a stream. So the data is being filtered to these two different apps. So, and it's based on one filter attribute, which is called the account type. So if the count type is premium, then it's going to send it to this app, this premium app versus the standard apps, right? So in this case, I'm just going to update the notes. So I'm going to update the notes in this case to live testing. So in this application, you see again the note just got updated to live testing, and of course the Howard accounts or the premium accounts. I'll do the same thing with the standard one. So in this case, again, I have this single application And this is the application that is going to send that data to RabbitMQ using AMQP 1.0, and it's going to filter to the standard account using the AMQP filter. All right, that's all I have. So maybe do we have any questions in
We
this
do,
live?
yeah. We've we've got a question, but we've also got a comment from Johan. Thank you very much, Johan. That there is a breaking change on the client side for AMQP 091. JavaScript clients need to be updated if you're updating to 4.1. So thanks for flagging that. That's excellent. The other question is, Greg. I'm going to throw this out to you on the hoof. What is necessary to switch from open source RabbitMQ to Tanzu RabbitMQ and Kubernetes?
Yes,
Do you
I was.
Docker in?
Yeah, I would say the level of effort of that, it depends on what you're using. So, for example, I talked about how you can deploy RabbitMQ on bare metal or on a VM environment. So that's just a matter of now, as Howard mentioned, you have on Linux, you have the RPM based install that you can use, right? So you can just switch out the package versions that you use to use the commercial version and have those additional commercial features. On a containerized environment, if you remember, I showed you the Kubernetes YAML, right, where I was specifying the actual image, right? The image that I was using, if you want to switch it from the open source to the commercial, it's just a one line of YAML change. Give that to the operator, and it's you're using the commercial features. Now I will say that the commercial features is based on open source. To your applications, you have zero changes that you need to do on the application side.
Cool. Thanks for that, Greg. Excellent. Well, that's it for the questions, and I think I've covered everything. Greg, have you got anything more that you want to say or add?
No, it's just I think on the slides we have a QR code. So each one of the demos that we showed, there's actually a open source public GitHub repo. So I would love for you folks out there that are watching this webinar to check out the link, check out the code, get started, and give us some feedback on the various use cases that you're looking for to deploy on with Rabbit.
Excellent. Well, Greg, thank you so much for helping me out on this update. Tremendous, because it's always nice to have something a little bit more meaningful than just a slide deck. So thank you so much for running these demos. I couldn't have done it without you. Well, yeah, I definitely couldn't have done it without you, because there's a reason why people like me don't write code. So thank you so much, sir. And thank you, everybody, for joining us. Excellent.
Thank